Let's talk about the integral regarding logarithmic functions. The general formula for this would be the integral of du over u. This would be equal to the natural log of the absolute value of u plus c. Any variables can be substituted in u, such as the integral of dx over x, but as long as you make it consistent. But for convenience sake, we will be using this formula because we will be mostly using a u substitution since it revolves around it. So without further ado, let us start with this first example. The integral of 8 over 5x plus 2 dx. So first, let us substitute u as 5x plus 2. You can base it according to this formula. Since what we want here is u on the denominator, substitute u as 5x plus 2. And so take the derivative. The derivative of 5x would be equal to simply 5. And for 2, it is 0. And multiply this by dx. And so, isolate dx. So what you have here would be equal to du over 5. And now, let us substitute all the values. So this would be the integral of 8 over u. And the value of dx right here would be equal to du over 5. And so first, let us bring all the variables outside the integral, or the constant I mean. So this would be equal to 8 over 5 multiplied by the integral of du over u. And now you can now see here, it is now according to the formula. So we can now integrate this. And so the answer would be 8 over 5 multiplied by du over u is equal to ln of the absolute value of u plus c. And so the last step would be to substitute u back into its original form. So this would be equal to 8 over 5th ln the absolute value of 5x plus 2 plus c. Next up would be the integral of y over 6y squared minus 1. So, first of all, when you're doing something like this, you must first check the powers of exponents. So, the power of exponent in the numerator is 1, and the power of exponent on the denominator is 2. So, if the denominator's power exponent is greater than the numerator, you can use u substitution. So let u here would be equal to 6y squared minus 1. But just in case you encounter a problem that the numerator has a higher power of exponent, such as the integral of y to the power of 3, what you must do here is to divide 6y squared, divide this. So this would be 6y squared minus 1 divide on y cube. This is what you will do to this. But since our exponent power is higher in the denominator, we will use u substitution. And so du here, which is the derivative of u, would be equal to 12y. Multiply this by dy. And since what we want here is a value of dy, we want to isolate dy here. So this would be equal to du over 12y. Substitute the values here. This would be equal to y over u multiplied by dy, which is equal to du over 12y. The y's would cancel each other out and put 12 outside the integral. But since 12 here is in the denominator, this would be equal to 1 over 12. multiplied by the integral of du over u. And so taking the integral of this is just formula base, which is equal to ln, the absolute value of u, plus c. So the final answer here would be equal to 1, this should be 12 1 over 12 multiplied by the natural log of u, which is 6y squared minus 1 plus c. Next up would be the integral of x squared plus 2 divided by x plus 1 of dx. So we can now see here, the exponent power of the numerator is equal to 2, and the highest power exponent on denominator is only equal to 1. So this has more power. So what we're going to do here is to divide it first. So this would be equal to x squared plus 2 divided by x plus 1. So x squared divided by x, this would be simply equal to x. And we cannot divide 2 to x since they are not common terms. So x multiplied by x would be equal to x squared, and x multiplied by 1 is simply x. So subtract this. X squared minus x squared would be equal to 0. 2 minus x would be equal to x minus, or this can be simply negative x plus 2. And so negative x divided by positive x would be equal to negative 1. 1 multiplied by x would be equal to negative x. 1 multiplied by negative 1 multiplied by 1 is simply negative 1. Subtract this. This should be equal to positive x, so they will cancel. 2 minus negative 1 is equal to 3. So you got a remainder of 3. So the form of the exponent right here now would be equal to x minus 1 plus the remainder, which is 3 over x plus 1 of dx. So let us simplify this first. This would be equal to x minus the integral of x minus 1 plus 3 over x plus 1 of dx. For simplification first, let us just split this integral into 3 parts. This is the first, second, and third. So this would be equal to the integral of x dx minus the integral of 1 multiplied by dx is simply dx plus the integral of 3 over x plus 1 of dx. And so take the integral. First, the integral of the first part, which is x dx, is equal to x squared over 2 minus the integral of dx is simply x. And now let us focus on this third part. We can see here now that it has a power exponent of 1, but since we don't have any x here, we can now conclude that the denominator has a bigger exponent power than the numerator, so we can use u substitution. So let u here be x plus 1. The derivative of x is simply equal to 1 multiplied by dx. So we can conclude that dx right here would be equal to simply du also. And so let us focus first on here. So this would be equal to the integral of 3 over u multiplied by dx right here would be equal to du. we can put 3 outside the integral. So this would be equal to 3 the integral of du over u. And so this can be now equal to 3 multiplied by the natural log of the absolute value of u plus c. So with that, we can put this in here. So this would be equal to 3 natural log of u plus c. And so the final answer would be equal to 1/2 x squared minus x plus 3 the natural log of the absolute value of x plus 1 plus c. The integral of 3x squared over 5x cubed plus 1. We can see here that the denominator has a bigger exponent than the numerator. So we can use u substitution. Let u here be 5x cubed plus 1. The derivative of 5x cubed would be equal to 15x squared. The derivative of 1, which is a constant, is equal to 0. So dx right here would be equal to du over 15x squared. Substitute the values. This would be equal to the integral of 3x squared over u multiplied by dx, which is equal to du over 15x squared. The x squared will cancel each other out. 3 over 15 is the same as 1 over 5th. And so, put the integral with, the constant outside the integral. So this would be equal to 1 over 5th, the integral of du over u. So this would be equal to 1 over 5th, the natural log of the absolute value of u plus c. And so the final answer would be equal to 1/5 multiplied by the natural log of the absolute value of 5x cubed plus 1 plus the constant of integration. The integral of 3x over x squared plus 4 of dx. So we have a bigger value of exponent now on the denominator again. So let u here be x squared plus 4. The integral of x squared would be equal to 2x, and the integral of 4, which is a constant, is 0. So dx right here would be equal to du over 2. Substitute the values. We would have the integral of 3x over u multiplied by dx right here would be equal to du over 2. Wait, 2x this should be 2x. So the x right here will cancel, and you can put the constants outside the integral. So what you have here would be equal to 3/2 the integral of du over u. So that will be left as 3/2 multiplied by the natural log of the absolute value of u plus c. Therefore, the final answer would be equal to 3 over 2 natural log of the absolute value of x squared plus 4 plus c. The integral of 2x cubed over x squared minus 4 of dx. You can see here now that the numerator has a bigger exponent than the denominator. So we will divide this first. So this would be 2x cubed divided by x squared minus 4. So 2x cubed divided by x squared, this would be equal to 2x. So 2x multiplied by x squared would be equal to 2x cubed, and 2x multiplied by negative 4 would be equal to negative 8x. So, first subtract this. So, 2x cubed minus 2x cubed would be equal to 0. 0 minus negative x is equal to positive 8x. And so, your remainder only is equal to 8x because you cannot divide 8x by x squared any further. So, your form of integral would look like this. The integral of 2x plus, because this is positive, the remainder, which is equal to 8x over x squared minus 4 of dx. First, let us split this integral into two parts. This is the first and this is the second, separated by an operator of positive or addition. So this would be the integral of 2x dx plus the integral of 8x over x squared minus 4 of dx. So take the integral of the first part first. This would be equal to 2x squared over 2. And let us now focus on the second integral. You can see here now that the denominator has a bigger exponent than the first one. So let us use the substitution. Let u here be x squared minus 4. The derivative of x squared would be equal to 2x. Derivative of this is simply 0. Value of dx right here would be equal to du over 2x. So substitute it. This would be equal to 8x over u multiplied by du over 2x. This will cancel and this will be equal to 4. And so what you have left here is equal to the integral of 4 du over u. You can put 4 outside the integral. So this would be equal to 4 integral of du over u. Integral of this would be equal to 4 natural log of the absolute value of u plus c. So put that. So this would be equal to 4. There. And so, simplify this and put u back into its original form. So, the final answer would be equal to x squared plus 4 natural log of the absolute value of x squared minus 4 plus c. Let us try now some trigonometric here. So the integral of sine 3x over cosine 3x minus 1 of dx. So let u here be cosine of 3x minus 1. So the derivative of cosine 3x, you can put it this way. You can put this as cosine 3x plus 1. So according to the chain rule of derivatives, you must first take the derivative of the outside the integral. The outside integral is cosine and the inner integral is 3x. So taking the integral of the outer first, which is cosine, the derivative of this would be equal to negative sine of 3x, and multiply this by the derivative of the inner function, which is 3x. The derivative of 3x is simply 3. The derivative of 1 is 0. And so simplify this, you would have negative 3 sine of 3x. Multiply this by dx. So the value of dx right here would be equal to du over negative 3 sine 3 of x. So substitute it. You would have the integral of sine multiplied by 3x over u multiplied by value of dx, which would be equal to du over negative 3 sine 3 of x. Sine 3x here would cancel, so you are left with negative 3 here. Put it outside. Since this is a denominator, this would be equal to 1 over negative 3, or simply negative 1/3. The integral of du over u. And so this would be equal to negative 1/3 multiplied by the natural log of the absolute value of u plus c. So the final answer here would be equal to negative 1/3 natural log of the absolute value of cosine 3x plus 1 plus c. The integral of x minus 3 over x squared minus 6x minus 1 of dx. So you can see here, we have a bigger exponent value on the denominator. So let us use u substitution. Let u here be x squared minus 6x minus 1. Take the derivative of each. X squared would be equal to 2x. Integral of 6x would be equal to simply 6. And the derivative and the integral of negative 1 is simply 0. And so multiply this by dx. Dx right here would be equal to du over 2x minus 6. Actually, we can factor this out. So dx right here would be equal to du over, factoring this, we would have 2 multiplied by x minus 3, which coincidentally matches this numerator for simplification of cancellation. And now substitute the values. So this would be equal to the integral of x minus 3 over u multiplied by dx, which is equal to du over 2 multiplied by x minus 3. X minus 3 would cancel here, which left to you a constant of 2. So you can put it outside the integral. So this would be equal to 1/2 the integral of du over u. So this would be equal to 1/2 the natural log of the absolute value of u plus c. And so the final answer here would be equal to 1/2 the natural log of the absolute value of u, which is x squared minus 6x minus 1 plus c. For the last problem, the integral of cosine 3x plus 3 over sine 3x. So, if you are not sure what to do here first, whether to simplify the integral first or use u substitution, I recommend using u substitution first to see if there are any complicated expression after. So let u here be sine of 3x. So the derivative of this, take the derivative of sine first, which is equal to cosine of 3x, and multiply this by the inner integral, which is equal to 3. And so du right here would be equal to 3 cosine 3x multiplied by dx. So dx right here would be equal to du over 3 cosine 3x. So if you substitute it into this integral, you would have the value of cosine 3x plus 3 over u multiplied by dx, which is equal to du over 3 cosine 3x. Now, we cannot simply cancel out cosine 3x here because you can see here, it has a part of plus 3. If only this would be equal to the integral of cosine 3x. If only this is the situation, you can freely cancel these two, just like the previous problems we have come it. But the plus 3 here is part of cosine 3 of x. So you cannot simply cancel this. So if you cannot cancel this and simplify, you would need to simplify the integral first and use u substitution after. So the first step here would be to split these two parts with the same denominator of sine 3x. So this would be the integral of cosine 3x over sine 3x multiplied by dx. Since this is addition, this would be plus the integral of 3 over sine of 3x of dx. So in this case, for the first part first, you can use u substitution. Focusing on the first part first, let u here in this case be sine of 3x. So the derivative of sine 3x, as we had solved earlier, it is equal to 3 sine of 3 cosine, of 3x multiplied by dx. So dx right here would be equal to du over 3 cosine of 3x. So putting this would be equal to the integral of cosine 3x over u multiplied by dx, which is equal to du over 3 cosine 3x. So you can see here, now we can freely cancel this cosine 3x. And we can put 3 outside the integral. So we are left with 1/3 the integral of du over u, which is equal to 1/3 natural log of the absolute value of u plus c, which makes this the answer of 1/3 natural log of the absolute value of sine 3x plus c. This is the answer for the first part. So let me just put this. So this is equal to this. Don't put plus c first because we need to find the integral of this. We can put this later on. And now that the first part is done, let us now focus on the second part. So first, we can put 3 outside the integral. So this would be equal to 3 integral of 1 or dx. We can put dx, or we can just put 1 over sine 3x of dx. So how can we solve this? We must know the properties of trigonometric identity. Wait. We must know this. The inverse of sine is equal to cosecant. And the inverse of sine, this is equal to 1 over sine. So we have here sine 3x. So if we want to take the inverse of this would be equal to cosecant of 3x. So the other form of this would be equal to 3 the integral of cosecant 3 of x dx. And so the next step here would be to use u substitution. Let u here be 3x. So the derivative of 3x would be equal to simply 3 multiplied by dx. So dx right here would be equal to 3 over, wait, du I mean, over 3. We did this because what we want here is a single variable such as cosecant u or cosecant x or something. But since we have 3x here, we must first eliminate that in order to have a single variable. So by substituting it, what we have here is 3, the integral of cosecant u multiplied by dx, which is equal to du over 3. You can see here that the 3's would actually cancel. So you are left with here is equal to the integral of cosecant u multiplied by du. Now, let us take the integral of this. But the solution here is kinda long to explain. But I explained this in my previous video, so you can just watch how the solution would go. But basically, the integral of cosecant of x dx would be equal to the natural log of the absolute value of cosecant of x minus cotangent of x plus c. So what we have here is cosecant of u. So just replace the variables here in x and replace this with u. So this would be the integral of cosecant of u. If you want the full explanation, just watch my previous video regarding cosecant and secant. So the final answer here would be to substitute u into its original form first. So this would be equal to the natural log of the absolute value of cosecant 3 of x minus cotangent 3 of x plus c.